Alrighty, thank you, Brian. For those of you who have not attended one of my workshops before, my name is Brian Wisniewski, and as Brian said, I work in the Research Commons as a data visualization specialist. Just a little bit about myself. I went to Ohio State, studied philosophy, took a lot of math classes, things like that, and then currently I'm finishing up my master's in translational data analytics here at the university. So we'll just jump right in. So kind of just the agenda for today. We're going to kind of go into what is Python, why we would want to use it, why we might not want to use it, some overall layout and terminology. And then we're going to show you some practical examples so you can kind of map this theoretical information to something a little bit more tangible, and then maybe take it away and do some of it on your own and see if it's something that you're interested in. And just disclaimer before we begin, this is the first time I've given this presentation, so there may be some unexpected speed bumps. We will see. So what is Python anyway? So Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. Wow. Okay. This is an intro-level seminar here, so let's back that up a little bit. What is a programming language? Programming language is just a language that we can use to interact with the computer and give the computer instructions so that the computer will execute our commands and do things for us that are a little bit too hard for us to do as human beings. So high-level computation and things of that nature. It's not that important to know what it means to be interpreted or object-oriented or high-level, but really what distinguishes Python from other programming languages is that it is that high-level element there that means that it's a little bit more abstracted out, which cashes out as a user as it's easier than other programming languages for us to program and give the computer those instructions. So it's a little bit more intuitive. So I want to show you a few things before we begin here. Hop over the internet. So in Python, there's what are called libraries, and libraries are collections of tools and commands and objects, things that we have packaged together so that when we want to accomplish certain tasks, we can more effectively do that by just importing this library. So one of those libraries that we use for data visualization is called, I think it's called matplotlib. That's how I've always said it. I've never heard anyone pronounce it. So, but this website is for matplotlib, and it has documentation on this particular library where you can find examples on how to use it and things of that nature. And for those of you who are sitting there saying, well, what is a library? Your explanation was horrible. Just be patient. We'll get to that later in the presentation. I'm going to go through some common terminology with computer programming so you kind of get in a sense of what I'm even talking about. But just know for the time being that matplotlib is this bucket of tools that we can use to create visualizations. So on this website, there's all sorts of documentation on different visualizations. So for example, bar charts, we can go ahead and click that, and it will demonstrate a very, very simple bar chart here. So this is how you could create this in a Python programming environment. And again, if you're new, you're probably saying, what is a Python programming environment? Well, I'll show you a very, very easy and straightforward one that you can get set up with almost no issues at all. I see something in chat. Let me see. Is it similar to ggplot2, like matplotlib for Python visualization, ggplot for programming, R programming? The purpose, I'll probably get to most questions at the end, but this is actually very relevant. It's a great question. It is very similar to ggplot2 in terms of its purpose. So its purpose is to create visualizations. In terms of its functionality, as in what it feels like to actually interact with it, it doesn't really function in the same way. But in Python, you can actually use ggplot2. So ggplot2 is available in both R and Python. So if you learn it for R, you can bring that skill set over and use that in Python and vice versa. And I'll also show you an alternative library that functions a little bit more like ggplot2 in terms of the way it the what's called the syntax, so the grammar of the library functions. So, but yeah, that's a great question. It is very similar. So for those of you who have attended my R session and seen the ggplot2 package, it is quite similar to that. And we'll actually go through that. If you recall that R code I showed you last time, I'm going to show you how to do all that in Python at the end of the demo if we have time, or at the end of the presentation if we have time. So you can go ahead and if you want to see how this works in Python, you can just copy and paste this into some programming environment. So I'll just do it here very, very quickly. I've never done this before. Hopefully it works. Fingers crossed. So there you go. It worked. So you could go in here and mess around with this and input your own data and generate this plot, if that was something that was interesting to you. So there's all sorts of things on here. There's tutorials as well. So you can go on here and see tutorials for other things. There's, like I just showed you, there's examples. There's plot types where you can come and learn about the various plot types available, but I don't want to spend too much time on this, but just be aware that Matplotlib is one of the more popular visualization libraries. So another very popular one is called Plotly. And same idea, but just a little bit different. So we're creating visualizations, and it can do basic visualizations all the way up to advanced ones. So it can, to my understanding, I think it can do, don't quote me on this, but I think you can do things all the way up to like animations, and you can do machine learning. So this is right here in particular is machine vision. So it's identifying objects in the street. So the possibilities are endless, but Plotly and Matplotlib have kind of been the gold standard for a long time. But this is very similar to that website I just showed you. It's just a different library. So you can come on here and press the getting started, get an overview of what Plotly is and how to install it and yada, 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 so on and so forth. Pretty much exactly what I just said, just a different library. You can come on here and explore this at your leisure. I don't want to spend too much time on this. And then this last one. So if you've been to other presentations, I think I have a similar website in my Intro to Data Visualization workshop, but this is the Python Graph Gallery. So it's kind of a version of that graph choosing gallery that I showed you in that presentation. This is basically it for Python. So we can go on here and see different visualization types. So let's say we want to look at a scatter plot. We can go ahead and click that and get a very basic introduction as to what a scatter plot even is. And then we can go down and see very simple demonstrations on how to create it. We can, if we have a particular type of scatter plot we want to create, we can hone in on a particular one. We can see how to create it in different libraries. So in addition to Matplotlib and Plotly, there's another very, very common data visualization library called Seaborn. And at the end of the presentation, that's the one that you're going to see. That's the one I'm going to use. And so you'll see that more towards the end. But this website has various instructional content on how to create visualizations with some common libraries. And it also has other things on here that you can observe, how to change the font in your visualizations, how to add titles and legends and annotations, change the theme, so on, so forth. So why would you want to use Python? So Python's simple, easy to learn syntax emphasizes readability. Programmers fall in love with Python because of the increased productivity it provides. So the advantage of Python over other programming languages, for example, R, is some people find it more intuitive and easy to learn, and it is faster to program certain things because it's more abstracted. So there's less commands that you have to give the computer to accomplish the same goal. So what would take you 10 lines of text or 10 lines of code in one computer programming language might only take you 3 or 4 in Python. So it's very efficient, it's very abstracted out, but with that abstracted aspect to the language, there are downsides. So it's easier to make certain type of errors in Python because it's so abstracted out. As you're abstracting out information, you leave room for ambiguity, which leaves room for error. So to be more specific, here are some pros. So it's free and open source, just like R, so it's completely free. It's widely used and supported in research, academia, and industry. It's the most commonly used computer programming language, and it's not going anywhere. It's very, very powerful, very popular. If you learn Python, you can go anywhere. Flexible and can integrate with other languages easily. Powerful libraries exist. We've talked about these three already. And it's good for standalone analysis as well as building web applications or dashboards. It's a little bit weaker on creating dashboards from my personal experience, right? So I am no expert in anything, but in particular, I'm no expert in Python. So perhaps somebody with a little bit more aptitude would disagree with me, but in my personal experience, I've found it a little bit more challenging to create things like dashboards and even web applications. I tried, and it was very challenging for me. I found it easier to do something like that in R, but I'm biased because I work in data science. So it's good for standalone analysis. So what does that even mean? It's good at being a place where you can take in your raw data and do everything that you need to do to get up and running to have visualization. So organizing that data and then cleaning it up, which means removing errors, removing values that don't make any sense, organizing and structuring the layout so that functions in your computer programming language can understand what the data means, et cetera, et cetera. Just getting the data ready to be turned into a visualization. It can do kind of everything. It's somewhat like R in that regard. Facilitates data wrangling and manipulation with libraries like pandas and NumPy. So what I was just talking about in terms of structuring the data and putting it into a layout that can be turned into visualization, that's kind of what I mean by data wrangling and manipulation. I think if you attended my lecture last week, I had a pretty colorful analogy involving crocodiles. I'm not gonna introduce you to that one today. It's too early for that. And then there's large community of developers offering resources, tutorials, and help. So Python is, because it's so common, and like I said, it's one of the most popular languages that are used. There's a ton of resources, and the resources are very, very, very good because they're relatively new. With something like R, because it's so old, you can kind of get into a situation where some of the resources are outdated, they haven't been maintained and updated, and you have a graveyard of obsolete information out there that kind of exists on the internet. And you have to be a little bit careful about what you're taking to be true as you're looking through all of that. With Python, some of that is still true to some extent, but to a lesser extent because it's a newer language. Make sure everyone can. Sorry, I was looking at the chat. Cons: it can be challenging to learn, not always intuitive, especially for beginners. It sounds like I just contradicted myself based on what I said at the beginning, saying it was intuitive. It's a matter of perspective. It's ultimately subjective. Okay, some people can learn computer programming languages when they're 8 years old and are programming computer games by the time they're 12. Some people can never pick this stuff up. It just depends on how you think. As far as the landscape of data visualization tools, I would say it's probably a little bit harder than most, but probably not as hard as R in terms of that upfront time investment and headache inducing work at the beginning when you're learning these things. What I think is most annoying as a beginner is actually setting up the environment for Python and learning even how to interact with the environment that you're programming in. But I'm going to show you a very simple environment to kind of bypass that so you can get started as a beginner. It's not as optimized for big data as other languages like Java or C++. I don't know about that. I know I made this presentation, but I'm not take that with a grain of salt, okay? Again, this information may be old news at this point. So the computer programming languages like Python are always being optimized, and it's probably the gold standard at this point for big data analysis because it's so easy. So yes, it may take a little bit longer to process very large data sets, but you're also saving time on kind of the front end when you're actually writing programs and whatnot. You're saving a lot of time on that because it's an easier and more intuitive language. So the jury's still out. This is something you'll have to kind of use your judgment on as you get further along. Not ideal for dynamic or 3D visualizations. Debatable. Again, you're probably going to be fine for what you're going to be doing here. If you're in it, if you get more advanced, there may be better options, but for the most part, you're probably going to be okay on that. Uses more memory than other languages, which can be a problem for very large data sets. It's true, but it's a little pedantic. So unless you're using massive data sets, you're probably not going to notice that, to be completely honest with you. But it is true, and it is related to why it is a little bit slower than other languages and not as optimized. That memory usage and this optimization point are related. This is causally determining it being less optimized basically here. So lacks basic security features, making it suboptimal for web applications. Again, niche cases, probably not applicable to you as a beginner. Debugging could be more difficult compared to other languages like R, MATLAB. That's actually kind of something that is pertinent as a beginner. So I won't get into the reasons why, but because of the abstract nature of the language, certain types of errors are more prevalent. And those errors are due to the ambiguity of the way you're defining things in the language because it's so abstracted out. So think of, this is a very, very rough example, but think about describing an event with mathematics versus describing an event with natural language. So there's going to be some information loss as you're using natural language, even though natural language is easier. You can't be as precise as you can with mathematics. That's very, very rough, but it's vague, very loose analogy there. So some overall layout and terminology for computer programming in general. This is applicable to probably any computer programming language you're going to use. So an object is a name that you can use to call up stored data. So if we have a list of values, 1, 2, 3, 4, 5, and we want to store that on our computer, we want to name that something. We want to have something that we can refer to reference that information in memory. So we could store that information as an object. In reality, what you're really doing is it's not storing it in the object. It's just basically labeling. It's pointing to that place in memory, but that's pedantic. It doesn't matter. Just know that an object in this kind of theoretical space that we're operating in as we're programming is a container for data. It's a place to store data. Functions are self-contained modules of code that can accomplish a specific task. So what I usually try to, the analogy that I try to illustrate when I explain this to people is, if you imagine baking a cake, that recipe could be considered a function in some sense. So the bake a cake algorithm, the series of steps involved with baking a cake and all of the things needed to bake that cake packaged together could be in some sense analogous to a function. Not really, but I don't know. I like talking about cake. So you'll see what a function is when we get there in a couple minutes, about 10 minutes here. Package is pre-assembled collections of functions and objects stored in your hard drive. So these two things put together are a package. So a package, let's say you want to accomplish a specific goal. So somebody who's done that task before, someone who had that same goal as you somewhere in the past, realized it was really annoying to go and find all the objects and functions they needed to do that goal. Maybe they needed to do that over and over again. Maybe it was creating a bar chart. Instead of every time needing to go and find all the objects and functions needed to create that bar chart, somebody realized, let's all package those things together into a neat little box so that we can just go grab the box every time we want to create that bar chart. That's basically what a package is. It's packaging together functions and objects with the intent of being more effective at completing a task or series of tasks or collection of tasks. A library, for practical purposes, is effectively synonymous with a package. So these are basically interchangeable in a beginner context here. So, more nuanced description of these, they're distinct, but for the time being, they're synonyms, whatever. Fine. So this is one example of an environment that you could program Python in. So this is called PyCharm. And I'm just going to flash this on the screen and point at it for 15 seconds, and we're going to move on because this is confusing. As a beginner, I think this is going to give you a headache, and it's going to make you not want to computer program. It's a pain to get these things set up as a beginner. But this is the editor. This is where you can edit code, create code. This is a status bar. It's telling you if what's happening. So if you're running a program, it'll tell you that it's running. This is a menu, has different options, and then a toolbar has some information there. You can run code with this little green arrow here, so on and so forth. But PyCharm is a really great what's called IDE, which is Integrated Development Environment, which is just a interface that you can program Python. So you create code in PyCharm and you run the code in PyCharm. Python is installed somewhere else on your computer, but PyCharm is interacting with Python, and then Python is talking to your computer and converting it into a language that the computer can understand. But this is just an interface that you can interact with Python, and it's easier than the default environment for programming Python that comes with Python when you download it. So you can download it here. So this is called Google Colab. If you may have heard of this, but so Google Colab is a place where you can program all sorts of computer programming languages, and it has everything you need to program already up there in the cloud. So it's in an internet browser. You can open it up on your phone. You could open it up on your computer. Everything's good to go. You don't have to set up anything. You can just start running code easy, and it's completely free. You just have to sign in with your Gmail. There are some restrictions on how much memory you can use and things of that nature, but it's probably good enough for getting started and to learn Python. And so this is what I'm going to show you in a moment here. Then downloading Python, you can go ahead and just, if you get to the point where you're installing Python and setting up an IDE, so installing Python and installing PyCharm, for example, I would assume at that point you're somebody who is fairly driven, and there are a ton of tutorials out there. So I don't want to use our time here because we don't have much of it walking you through that. There's tons of tutorials out there, and I would not recommend going that path unless you're really serious about moving forward with learning this stuff. I would start here in Colab and see if it's something that you even think is useful to you. So I'm going to go ahead and show you some code. Before we do that, just be aware that I am available for consultations, and also that there are we have these guides that you can use that have a bunch of information. I'll send out a link after. You can go explore that. For the time being, we'll focus on the Python. But I will say very quickly, because I have to plug this, it's my job, schedule a consultation with either myself or Sarah Murphy. So I do more R, and recently started doing more Python as well. I'm a little bit better at R, but I can do some Python. And Sarah is more involved with Tableau and Excel. So, okay. Let me check chat very quickly. I'm keep losing your audio, and I'm getting messages that my internet connection is unstable. Okay. Is everybody good? Can someone confirm that the audio is okay? Are we good on audio? Awesome, excellent. Thank you guys so much. Okay, nice. So if you were at my R spiel last week, I went through this code in R, so it's the same exact data set and everything. But for those of you who are new, this data set is called MPG, and it has information on, I'll show you, car makes, models. So we have the manufacturer, the model, the displacement of fuel in the engine, the year it was released, the number of cylinders, the type of transmission, the type of drive, the city highway fuel efficiency, the highway fuel efficiency, or the city fuel efficiency, the highway fuel efficiency, I forget what FL is, and the class. Doesn't matter. I chose this data set kind of on purpose because the fields are pretty neutral. There's no, I don't want you to get lost in the context. I want you to kind of think about this stuff as in just keep it abstract. Like this, just think of these as data fields. Just know that we have these different fields. And by the way, when I say fields, any of these column names, this is a field. So for your own understanding, manufacturer is a field. One is a record. So this whole row is a record. Rows are records. Columns are fields. And this numbering 1, 2, 3, 4, 5 is called an index. You care? So before we begin, I'm just going to walk you through the code. Since we have plenty of time, I'll be a little bit more in depth here. So we have this import seaborne objects as SO. So what we have here is import, which is bringing in a library. We use that to tell Python that we want to bring in a library. And this dot objects is a specific subset of this seaborne library. So this dot objects, this objects subset is very, very new. It's the most recent. It's a very recent release for this library. So it's a little bit, it's a work in progress, but it's very good and I like it. And I chose this because it's more similar to ggplot2. So if you were in the R session, this is a little bit more similar to the style of ggplot2 than just the regular seaborne. And then when we put as SO, we're just saying we want to import this, and instead of typing seaborne.objects every time I want to reference it, I want to have a nickname for it. So as SO, you could, I think you name it anything you want, but so for right now, SO. And then import pandas as PD. So pandas is another library. This library is used for manipulating data and cleaning data. Seaborne is for visualizing data. And then because I needed it for a specific visualization, I imported just the regular seaborne library. And then to import the data set, I'm going to store a data set and I'm going to call it MPG. So this is an object. This MPG is an object. And I want this object to be something. So I'm saying it's equal to something. And what do I want it to be? Well, I want it to be equal to this MPG data set that exists somewhere. This is the path to it. It's pointing to it. And this PD is, as you can see up here, we imported pandas as PD. This right here is saying we want to use a function from pandas. So we want to use something from PD, and we want to use the read function. and it's specifically a read CSV function. So in the pandas library, there's a function called read CSV that we can read information from a CSV file, and then now we're setting it into equal to this object. So now all that information is stored in MPG. So when I called this object, it is spitting out all of that information from the CSV file. So a CSV file, if you're not aware, any Excel file you can save as a CSV file. Okay, so before we begin, I just want to, I forgot to mention this Google Colab. If you just go to Google Colab and sign in with your Gmail, and then go to new notebook, it'll bring up a blank notebook with these are called cells, and then you can start putting code in here, and then you can just run the code. So if you want to follow along, you can, but it's that easy. You don't have to do anything, and it'll tell you all sorts of RAM and memory information up here if you're interested in that. Okay. So let's create a scatter plot. So what we have this so.plot. So so, as you recall, was this seaborn.objects as so. So we want to use that seaborn.objects library, and we want to use a plotting function. And so what do we want to plot? Well, we want to plot, here, I'll type this out. It might be a little bit more clear. So we have so.plot. So Seaborn library, what do I want to do in the Seaborn library? I want to plot something. What do you want to plot? I want to plot the MPG data set. Okay, can you be more specific? Sure. I want to have an x-axis and a y-axis. Well, where do you want your x-axis? Okay, well, I want my x-axis to be, let's pick one of these variables. How about displacement? So quotes, go into this data set, go into MPG and go find something called dispel. And it'll go through all of these columns and it'll look for something called dispel. If I put a space here, it'll now go look for dispel space and it won't work because dispel space doesn't exist. It has to be exactly you could copy and paste this like this, copy and paste, Control C, Control V, whatever you want, but it has to be exactly the same. You can also reference it by number. So you could reference it by it being the third column, but we're not going to do that. So let's have a y-axis as well. Okay, let's do HWY. Okay, so what does this do? Cool. So it did exactly what I told it to do. It created a plot with an x-axis and a y-axis. There's no points on it. Why? Because this plot function creates a coordinate plane. This x and y is defining an axis. We didn't tell it to put any points on there. So computers only do what you tell them to do. So what do I want to do? Well, I want to add something. So I'm going to do dot add. Pretty straightforward, right? And then in that seaborn.objects library, there's a function called dot. Why is it called dot? Because it's going to add dots. It's going to add the points to our graph. So let's see what happens when we do that. Well, there you go. So now it added dots, right? So we told it exactly what we wanted to do and it did it. And so if we wanted to add a title, you could do dot label, and then you can tell it, okay, I want to change what the x-axis is called. So what do I want to change? I want to change what x is. Same with y. You can change what y is. You can change what the actual title is. And you can see, oops. You can see how when I make this parentheses, it's creating this little box around this parentheses. It's showing you that this open parentheses here is corresponding to this parentheses here, so that you can make sure you have the correct number of parentheses. That's what that's doing. So there you go. So you just created a plot. Took 5 seconds. Easy. So let's move forward. So we have this is all from what we just had. We have SO plot. Let's do MPG, same exact variables. Yeah, so this is exactly what I had before, but this time I want to represent a third variable here. Okay, so how do I want that variable to be represented? Well, there's any number of ways we could represent it. Let's say we want to add color. So we want to have a third variable represented in a dimension of color. Well, we can tell it, hey, I have this X axis, this Y axis. I don't want to make a 3D graph, so I don't want a Z axis, but I want another way to represent some information here. How about we have a third dimension to this color, and let's choose, we chose class here, so let's just go with class. And then as before, it's the exact same situation. It's just going to create that coordinate plane unless we tell it to add dots to it. So dot add, and then this dot function doesn't exist in base Python as it is. Somebody created this dot function and then put it into this package because they got tired of using the functions available in Python because they were clunky. So as you can see, it took that same plot we had from before, but it added a new dimension for class, and it assigned it color because that's what we told it to do. And it created this legend because it's smart. So somebody created this function so that the legend was automatically created. And you could change the label on that legend using this dot label function. What you would do is you would just write color equals and then name it like that. I'm not going to create the titles because I've already seen that. So I'm going to move forward here because we have time for questions. So this is the same exact idea, but instead of color, I wanted to have a different way of representing the information. Let's say we're worried about accessibility and we want to make sure colorblind people can see our visualization and understand it. We could use something called point size. And what did it do? It assigned different size points to each of the members of this variable, this class variable. And then when it plotted the point on here, it plotted it according to whatever size it was assigned. So, for example, this one up here that has a displacement of 1.8 or something, and a highway fuel efficiency of 44 miles per gallon. That one is a compact. So this point right here is a compact car with those X and Y values. Similarly, we can do something called alpha. So if you don't like point size, we can do something called alpha, which changes the I think this is the term opacity. Changes the how transparent the point is. So subcompacts are very faint, whereas compacts are very not faint. Okay, so this down here is where it starts to get a little bit hairy. Oh, also we have this right here. So when you add, you can also define what's called an aesthetic in this SO dot function, and you can say, I want these points to be a different color. The way you could do that is inside this dot function. You could say, I want this color, I want it to be purple. Right. So if you don't like the color black, or for some reason you can't, for whatever reason you want to change the color of it, that's how you can do that. We're almost done here. So I know we probably have some questions. So probably 5 more minutes. So let's do this again. So let's say this SO.plot that I'm copying and pasting here, this is exactly from before. Okay, this is what we've been doing the entire time we've been playing around here today. Completely the same. But and instead of, I want to have a third variable, but I don't want it to be like this. I don't want it to be on this plot. I don't want it to have an alpha value. I don't want it to have a different point size or color, but I still want to represent that variable. And I have a ton of points and it's really confusing. I want to just have separate graphs for each of this third variable. So I want to see the displacement and highway fuel efficiency for cars broken down by the number of cylinders that it has. So this dot add right here, all of this is exactly the same thing. The only thing that changes is this facet here. So this is called faceting. We're adding facets to our visualization. So when we do that, I don't know, I just ran it again. This is what you're going to see. So you're going to have the displacement and highway fuel efficiency, but up here, you're going to have a label that indicates which cylinder or how many cylinders that particular set of points has. So in this data set, there only exists 4, 5, 6, and 8 cylinder vehicles. And so that's why there's 4 facets here. And you can mess around with the aesthetics of this to change the way it looks. Okay, so let's say we want to do something similar, but we have 2 variables instead of 1 variable. So we want to create something like this faceting, but with 2 variables. So this is where instead of using this SO, I am going to use, I'm going to go back up to the top here. So this is why I imported just the Seaborn library. And this is the only time I'm using this in this entire document, is for this last one, because I couldn't figure it out with this new one here. It was confusing me, couldn't figure it out. This is very, very new. It's only like a year old, and I couldn't be bothered. So that's why we're doing it this way. So this time I'm going to just store it in a variable. Let's just call it like graph. And then we're going to use that SNS library. Then we're going to do something called facet grid. I'm going to use the MPG dataset, and we want the columns to be the number of cylinders and the row to be the drive. And what happens when you do that is it's creating coordinate planes where we have these variables mapped out here as and broken down by those variables there, but that's not very useful. So we can map on a scatter plot. You know, this is a little bit more confusing than the other ones, which is why we used that SO dot object to begin with, is because it was easier for the other examples. I'm sure it's easier for this as well, but see how much more confusing this is. So let's just run it and I'll show you what happens. So you can see what we ended up here with is kind of similar to up here, kind of a similar concept, but it broke down the scatter plots with more than one variable. So instead of just the drive or just the number of cylinders, now it's also broken down by the number or the type of drive that vehicle has. So on the x-axis, we have the displacement, y-axis, we have the highway fuel efficiency, and we still have that 4, 5, 6, and 8 number of cylinders, but because it's also broken down by the type of drive, there's more combinations here. So there are 4-cylinder engines with front wheel drive, rear wheel drive, whatever, and 4-wheel drive. Cool. So that's basically it. So I can share this notebook with you guys. Alternatively, I'll also send you a textbook. So I ripped most of this out of a textbook. So I'll send you the textbook. It's pretty good. It's very similar to the one if you were at the R session, it's similar to that one that I sent out for that, but it's just for Python instead. So, okay, so let's look at questions. So we have to remember here, there's Q&A and chat. So let me see. I'm going to have to scroll up here. Can you use regular expressions here in case there's some complicated number or something after the main keyword that you don't know or want to type out? Yeah, so I'm thinking when you asked this question, I'm thinking you were right here when we were referencing the columns. So you can reference the columns by the index as well. So you can do it that way as well. Are the default colors accessible, or is it possible to use custom colors? The default colors are I'm not sure if they would meet. I don't think they would meet Ohio State's qualifications for accessibility necessarily. And can you use custom colors? Yes, you can. Is it easy or straightforward? That may be a little bit more. That I don't know. I've actually never done that. I'd have to look into that. If you are trying to do that, you want help with that, reach out to me and I'll look into it. I don't know off the top of my head how to use custom colors. Yeah. So I'm not sure about the Google base code editor, but for some IDEs like PyCharm and Visual Studio Code, both free, I prefer so you can change color scheme. Yeah, so yep, changing the color scheme is nice. You can change these to what's called dark mode, so it's not white, it's black, the background, and it changes everything. And if you've ever seen movies where like the hacker has the green text on the screen, you can have environments like that if you want to scare people in the library. So what is the best way to export high quality figure from Python for publication purposes? It depends on what environment you're programming in. That's what I would say. So, you could copy and paste it right here, and then you could, if you're working in Colab, you could copy and paste like that. And you could also, you can export from Colab, but if you're using a specific IDE, it would depend on the IDE that you're using. But if you ever export a figure and the resolution isn't high enough, let me know. I can help you with that. So you can go into Photoshop and you can raise the resolution of images, and Photoshop is smart, and you can maintain the aspect ratio of the image so that you can increase the resolution and what's called the DPI. So you can get it into a form that's good and high quality for publication. So even if you have a low quality image, even if you copy and pasted this in 5 minutes, you can go into Photoshop and edit that image. I may have just missed the explanation, but are things like so.plot always referencing the format package? Always referencing the format package dot function. Yes. So if you see this, I think I understand your question. I think so. This so.plot is always in that format. So yeah, so that's, if you ever see this like that, that's what it's doing. This so.plot, this right here is always going to be a function. Though actually, yeah, yes, you are correct. Remember to use best practices when exhibiting this data. Alt text would probably not be the way to go, so explanatory text is key. Thank you. Okay, let me see here. Make sure we don't have anyone in the Q&A. Yeah, last time we forgot about the Q&A, so it's good. It's kind of good nobody used that, to be honest. So Richard, thank you, Richard, for posting that. So Richard posted let's open it and look at this really quick. So he posted a guide on alternative text, and I'm not familiar with this page, but what it looks like we're seeing here is some guidance on creating accessible content. So specifically, this particular type of text. So Ohio State has very specific standards for accessibility. So thank you, Richard. This is extremely useful. I'll send this out as well, unless people want to just grab it from the chat. But I'll send this out as well when we set up a follow-up email. Thank you for that. This is very useful. I'll have to keep that in mind for my own work. Nobody has any other questions. I think we're probably about good to wrap up. Brian, I don't know if you're still in here. Oh, here we go. Yep. So as you can see, Brian is saying that there is a survey if you want to fill out a survey and explain about your experience today. Fill that out. Absolutely. Thank you all for coming. I appreciate your time this morning, and keep an eye out. We put on different workshops. I do one for R. I do one for the intro, for an introductory level 1 for data visualization. And if there's a need for it, we can offer more comprehensive or more advanced material on this stuff. If people are interested, I could do an intermediate level 1 for this, or for R, or whatever. If you have any ideas, feel free to let us know in the Research Commons. Always looking for ideas to help fill needs on campus. So thank you all. Hopefully you got some time away from work, blocked out some time from work if you guys are employees at Ohio State. So Brian, are we good? Should we